All right, so this is 8.6 common logarithms. And the difference between common logarithms and just logarithms we've been dealing with is that common logarithms always have a base 10. So the little b that we always talk about, that's always going to be 10. And usually, if you have something that looks like this, the 10 might not be there. If you see this, it just means log base 10. So this means log base 10. Right? So for our first type of problems we have, it's evaluate. And this we use the calculator the entire way. We just hit log, which log is right here. So you hit log. We want to evaluate 5 and enter. And then your answer is 0.698972343. We need to be completely accurate, so I don't want you to round, but that would be what log 5 is. And you just use the calculator for that. For part 2, for solving, you know how before when we had logs on both sides we would cancel them out, but you can, instead of canceling them out, bring them back as long as it's the same base. So we're going to use common logs to do that. So I'm going to have log 3x, so log base 10 times 3x, 3 to the x, equals log 15. Using the power property that we talked about yesterday, I can move this x in front. So then it becomes x times log base 10, 3 equals log base 10, 15. Now I want to get x by itself, and if it's multiplication, I can divide log 3, divide log 15 here. So I get x equals, and then I have log over log is 15 divided by 3. So I have log 15 divided by log 3, 2.46497. So x equals 2.46497. That's for saying for one of those types of problems. And now for B, we're going to do the same thing, except it's just an inequality, but you're going to do the exact same thing. We're going to add logs in here. We're going to use that power property to bring the exponents in front. So we have y times log 4 is less than or equal to 2y plus 1 log 5. And since there's multiplication going on here, I'm going to keep the left the same, but I'm going to kind of distribute right here. So we have y times log 4 is less than 2y log 5 plus log 5. Now I want to get all the y's to one side. So I'm going to subtract 2y log 5. This would be like kind of like subtracting just like 4x or whatever. We just bring the whole thing along. Minus 2y log 5. And here we now have y log 4 minus 2y log 5 is less than log 5. Alright. Now the last thing that we can do, or almost last thing, is we're going to, these both have a y in common, so I'm going to group out a y. So now I have log 4 minus 2 log 5 is less than log 5. Bring the work up here. Now that this is multiplication, I can just divide away. So I have y is less than log 5 divided by log 4 minus 2 log 5. And you can plug that all into your calculator, and you will get y is less than negative 0.8782. Well, what a problem, eh? So again, just to break it down, we add in logs, we then bring the exponents around, then we distribute over here. We want to get all the y's to one side, so we subtract this entire thing. Now that we have this, we can group out a y, and then we can divide away. A lot of the same concepts we've always done, but with logarithms it makes it seem more complex. All right. Then the last part of this is change of base formula. And what this allows us to do is to find what log base 6/8 is using common log. So using common logs, we can find what that is. The formula just states that the little number is a, this number is n, and you're going to have log base 10 n over log base 10 a. So for us, that's log 8 over log 6, which if you plug this into your calculator, log 8 divided by log 6, you get 1.16056, and that is your answer. Other than that, what is going to be due for tomorrow is the worksheet I'm handing out. But that is what I have for you. Probably the most difficult parts are going to be solving. You probably have questions that will be like this, a little bit easier, and then ones that are more complex, like that.